Let us discuss a chapter Fourier series. In that, the first definition is periodic function. Periodic function means here we are taking sets. Let A is subset or equal to B. Subset of B means here A is the domain set. Okay, this is subset of B, and F is a function from A to R. R is the real number set. F function mapping from A set to real number set. It is a function. Then F is called the period of function or period function. F is called the period function if there exists a positive number small p belongs to capital A such that, or positive number, whatever the positive number, that is it's a positive real number, not a positive real number, such that x plus b is also belongs to capital A. This is the first condition for all x belongs to A. And the second condition is function of x plus p is equal to function of x for all x belongs to A. Then here p is said to be period of x. Whatever the positive real number, the small p is said to period of f. For example, we are taking f is a function that from A to R. Here the function can defined as f of x is equal to sin x. Okay, we are taking the p is a period. This is a real number 2 pi. 2 pi means it is a belongs to capital R. Then we are getting f of x plus 2 pi is equal to sin 2 pi plus x. Sin 2 pi plus x is again we are getting sin x. Here just we are observing here f of x is equal to sin x. F of x plus 2 pi is also sin x. Here 2 pi is the period of f. What is that? Sin x. Okay, this is the period of f. In the same way, if p is the period of f, then the functions are equal. F of x equal to f of x plus p equal to f of x plus 2p equal to f of x plus 3p plus so on. So equal to so on equal to f of x plus np equal to so on. So here whatever the function, either it is the positive numbers, that is f of x plus p or f of x minus p, f of x minus 2p. In both cases the n is a positive integer. In both cases the function becomes f of x. Okay, so such case we said to that p is the period of f. Okay, here we take the so many examples. If f of x is equal to, we define in sin x, f of x is equal to cos x, f of x equal to tan x, cot x. If sin x and cos x period, after 2 pi we are getting the same function. So 2 pi is the period. In tan and cot we repeated the function, no change of the sign for period pi. Okay, these are the examples for the different functions. Next, we discuss about the definition of the Fourier series. How to define. Okay, what is the definition of the Fourier series? How to express the Fourier series? Fourier series means a periodic function f of x. F of x is a periodic function. This is defined in the interval of length 2 pi. 2 pi is the length of interval. we can take the interval is the first is element is c, then c plus 2 pi, or simply 0 to 2 pi. Okay, or we defined as minus pi to pi, c to c plus 2 pi, or 0 to 2 pi, or minus pi to pi. It can be expressed in the form of f of x equal to a naught by 2 plus a1 cos x plus a2 cos 2x plus so on plus an cos nx plus b1 plus so on plus b1 sin x plus b2 sin 2x plus so on plus bn sin nx plus so on. Okay, that is nothing but we can write in the other form, that is or f of x equal to a naught by 2 plus a1 cos x plus b1 sin x plus a2 cos x cos 2x plus b2 sin 2x plus so on plus an cos nx plus bn sin nx plus so on. This is called as Fourier series. The expression of the Fourier series is f of x equal to a naught by 2 plus a1 cos x plus b1 sin x. Simply we can express it is in the summation form a naught by 2 plus sum of n equal to 1 to infinity an cos nx plus bn sin nx. This is the summation form. Okay, here a naught, an, bn are constants. Here what are the constants? A naught, an, bn are constants. Here n from 0 to infinity or 0 to so on, not infinity. Why? It's a natural number. In the natural number we are not taking the infinity, 1, 2, 3 so on. Okay, those are constant. Such a series is known as Fourier series. Okay, here a naught, an, bn are constants. Those constants are called as Fourier constants. These are called Fourier constants. The expression of the summation this series is called Fourier series. Here the Fourier constants, how we are taking, what are the definition, how to define the Fourier constants. Okay, here from the Euler's formula we get the Fourier constants a naught equal to 1 by pi integral c to c plus 2 pi f of x dx, a n equal to 1 by pi integral c to c plus 2 pi, an is related to cos nx, so f of x cos nx dx, bn equal to 1 by pi integral c to c plus 2 pi f of x sin nx dx. You have to remember the Fourier series expression and the Fourier constants. Fourier constants, how they express, okay, in the full wave. Now we discuss about useful integrals, how we get the integral values in the definite form. Definite form means the function can define in the particular integral. In that, first we are taking integral c to c plus 2 pi if the form is sin nx dx. We know that sin nx integration is minus cos nx by n, limits from c to c plus 2 pi. Okay, it will be 0. Why? Cos of n into c plus 2 pi. 2n pi plus c is cos c. Taking how we are getting means 1 by minus 1 by n is constant. Upper limit cos of c plus 2 pi n into c plus 2 pi minus cos nc. It is equal to minus 1 by n, 2n pi plus nc. What we get 2n pi means it's a repeated. Why? The periodicity of cos function is 2n pi. So we get cos nc minus cos nc. These two are get cancelled, it will be 0. So you remember integral c to c plus 2 pi sin nx dx is equal to 0. Okay. Second one, integral c to c plus 2 pi cos nx dx. Cos integration is sin nx by n, limits from c to c plus 2 pi. Take upper limit 1 by n sin n of c plus 2 pi minus sin nc. Again it is in the form of same. This will be 0. Why? 2n pi plus c. It's a first interval. First quadrant we get sin nc minus sin nc. It is equal to 0 in both cases if n is not equal to 0. The condition should be n is not equal to 0. Okay. These two. You remember integral c to c plus 2 pi sin nx dx value is 0. Cos nx dx value is also 0. Third one. Integral c to c plus 2 pi sin mx cos nx dx. This is in the form of sin a cos b form. 1 by 2 integral c to c plus 2 pi. Sin a cos b form means sin of a plus b plus sin of a minus b. Whole dx. Okay. It is equal to 1 by 2. Sin integration is 0. So it is 0, it is 0 when the finite integral c to c plus 2 pi. What sin integration is? Minus cos of m plus nx by m plus n minus cos of m minus n x by m minus n, limits from c to c plus 2 pi should be 0. Whatever the x coefficient, so that is we get the same terms, it should be 0, 2n pi or 2m plus n pi. Okay, either 2 pi, 3 pi, 2 into 1, 2 into 3, 2 into 4, 2 into 5, whatever the thing, we get the first quadrant only. Okay, the fourth one, integral c to c plus 2 pi cos mx sin nx dx. Cos a sin b form, that is equal to 1 by 2 integral c to c plus 2 pi sin of m plus nx, that is a plus b, minus sin of a minus b. Should be 0. Sin integration, after that the finite limit is 0. Here m is not equal to n. Here also m is not equal to n. Okay. The 4 cases, in 4 cases the integral value is 0. The expression of only sin, only cos, sin cos. Okay. Next, fifth one. Integral c to c plus 2 pi cos mx cos nx dx. It is equal to cos a cos b form. Cos of a plus b plus cos of a minus b. Integral c to c plus 2 pi cos of m plus n of x plus cos of m minus n of x whole dx. We know that in the integration of second case, cos, in both cases only the expression of the integral cos. If m is not equal to n, it is equal to 0. Next, sixth one, integral c to c plus 2 pi sin mx sin nx dx. It is equal to sin a sin b form minus 1 by 2 integral cos a cos b cos of sin a sin b c to c plus 2 pi cos of m plus n of x minus cos of m minus n of x. Here minus means we take first plus. If we are not taking minus means first term gets m minus n. In this case also we get the 0 if m is not equal to n. Okay. Why it is expressed in individual terms of cos. When it is individual of cos, the integration will become 0. Here you identify if the integration is in cos nx 0, sin nx 0, cos and sin 0, sin and cos 0, cos and cos 0, sin and sin 0. Seventh one, integral c to c plus 2 pi cos square nx. It is a repeated m equal to n case, m equal to n case. Cos square nx means we use the cos 2x formula. Cos 2x equal to 1 minus 2 sin square x 2 cos square x minus 1. From this we can write it as integral c to c plus 2 pi, that is 1 by 2 1 plus cos 2 n x dx. Okay, it is equal to 1 by 2 integral of 1 dx is x, limits from c to c plus 2 pi. We know that cos 2 nx integration is 0. So 1 by 2 into c plus 2 pi minus c. C cancel, 2 ones are 2 ones are cancel. What is the answer? Pi is the answer. Okay. In the same case, integral c to c plus 2 pi, if m equal to n, then sin mx sin nx becomes sin square nx dx. It is equal to 1 by 2. Use again cos 2x formula. Integral c to c plus 2 pi 1 minus cos 2 nx whole dx. It is also equal to 1 by 2. One integration is x, limits from c to c plus 2 pi. The remaining integration after the limits we get the 0. So this is equal to 1 by 2 c plus 2 pi minus c. It is equal to pi only. Just to you remember, cos square nx dx sin square nx dx values are equal to pi. Okay. First 6 are zeros. Next, if the expression is square in sin and cos, it is equal to pi. Next, ninth one. Integral c to known limits here, whatever the uv dx form or u dv. u dv, that is equal to uv minus u dash v1 minus plus u double dash v2 minus u triple dash v3, so on. Okay, these are the infinite. 10th one, integral e power ax cos bx dx. These are the basic formulas in the previous semesters. E power ax by a square plus b square. These formulas will again come in the Fourier series. A cos bx plus b sin bx. Okay, 11th one, integral e power ax sin bx dx. It is equal to e power ax by a square plus b square. A sin bx, sin integration is minus cos, so b cos bx. Cos integration is sin, so the second term is positive. Here sin integration is minus cos, so the second term is negative. What is the difference means? You remember like that. Next, 12th one. If sin nx is equal to 0 and cos n pi equal to minus 1 whole power n, then sin of n plus 1 by 2 into pi equal to minus 1 whole power n. Why? N pi plus pi by 2. Pi by 2, sin of pi by 2 value is 1. If n pi means that becomes in the second quadrant or fourth quadrant, whatever. So pi by 2 plus n pi means either negative or positive of 1. Here also n pi equal to minus 1. Why? Cos 0 equal to plus 1. Cos pi equal to minus 1. Cos 2 pi equal to plus 1. Cos 3 pi equal to minus 1. So 3 means odd, so minus 1. Here n equal to 1, cos pi by 2 is that is the pi by 2 plus whatever that is equal to minus 1. Okay, in the third quadrant and fourth quadrant, in those two sign is negative, the second positive. That is a repeated where it is either plus or minus. And cos of n plus 1 by 2 into pi, in this case it will be 0. Cos pi by 2 value is 0. So n pi means the cos term is only we get. N pi means again sin function comes sin pi by 2. Cos n pi means cos function will come cos pi by 2. Cos pi by 2 value is 0 whatever the quadrant. But here the changes of the pi by 2 value is 1. That depends on the quadrant, it either be minus 1 or plus 1. Okay, 13th. Even and odd functions. What is the even function? F of x equal to f of minus x. This is called even function. F of minus x equal to minus f of x. That function is called odd function. Okay, here even function examples are x square, cos x or cos x. Odd functions examples are x and sin x. Okay, these are the examples of even and odd functions. When the function is even, if f of x is even function, then integral c to c plus 2 pi f of x dx is equal to, or we are taking 0 to 2 pi or simply minus c to c f of x dx equal to 2 integral 0 to c f of x dx. If f of x is odd function, integral minus c to c f of x dx is equal to 0. It's very, these 13 formulas are very important. If it is even function with the negative sign and positive sign of the same limits, then you take double of 0 to c. If it is odd function, the function integration will become 0. Okay.